Hi everyone, welcome back to Eve Math Tutoring. Today's lesson is on multiplying a binomial by a binomial, and we're going to be using FOIL to do that. So the first thing is, what is a binomial? So a binomial is, what you have is you'll have something like the following. So I'll just start with a simple example here. So you might have something like a plus b. So that's a binomial. So it has two variables being added to each other. If you're multiplying by one binomial by another binomial, you're going to be using the rule of FOIL. So FOIL is F represents the first terms, O represents the outer terms, I represents the inner terms, and else represents the last terms. Okay, so if you're multiplying something like this, you're going to do the first terms, the outer terms, the inner terms, and then the last terms. That's the order in which you will multiply binomials by binomials, and we're going to be using this rule even for trinomials and bigger type situations. Okay, so starting off with something like this though, we would just have a times a, which is a squared, and then a times c, which is ac, and then b times a, which is ba, and then b times c, which is bc. So that would be the answer for something like that. Now commonly you'll see questions like this being presented more in this type of situation where you have, say, x plus 3 times x minus 4, something like that. Okay, so again, when you have to multiply or multiply the following, so what you're going to do is, when you have something where you've got a plus or minus inside one bracket and you've got same thing going on here, and you're multiplying both of them, because this is not just one number, you can't just take it and multiply it in. So you kind of are multiplying this by both, but in order not to mix up the signs, FOIL usually helps so that the signs don't get mixed up. So I would recommend using FOIL in this situation. So what you're going to do is you're going to multiply the first terms, outer terms, inner terms, and last terms. So x times x is going to be x squared. X times negative 4 is negative 4x. 3 times x is positive 3x, and 3 times negative 4 is negative 12. Now at this point, you see that you have like terms. So these two are like terms because they both have x's attached. So you would go ahead and add those. So negative 4x plus 3x is just going to be negative x, and then you just put in the minus 12. So that's how you would simplify something like this. Okay, so you would multiply it in the following fashion. And we'll just do a few more examples. So you can have all sorts of examples. You could have y plus 3 times y plus 10, and the question is to multiply. Okay, so in that case, you do first terms, outer terms, inner terms, last terms. So that's using FOIL. So we have y squared plus 10y plus 3y, and then plus 30. And then at this point, these are like terms because they both have a y attached, and the exponents of the y's are just 1. So that would become 13y plus 30. So that would be your final answer. Okay, so you could get situations where you've got higher exponents. Like say you have an example where you have x squared plus 2, and then maybe x squared minus 5, something like this, and you're asked to multiply. Okay, so you're going to do the first terms, outer terms, inner terms, and last terms. So x squared times x squared, as you know, when you have the same base, you just add the exponents, so that becomes x to the 4. And then x squared times negative 5 is just negative 5x squared. And then 2 times x squared is 2x squared. And then 2 times negative 5 is negative 10. And then at that point, you want to see if you have any like terms. So now you start using the rules of adding and subtracting in algebra. Okay, so with algebraic expressions. So you go back to figuring out, do you have like terms? Can you simplify this expression any further? And actually you can, because if you look carefully, this and this are like terms. They both have an x squared attached. So the x4 does not have a like term anywhere here. So I deal with these two. So negative 5 plus 2 is going to be negative 3x squared. And then, oops, and then it's just minus 10. Okay? So there's no other numbers to be like terms with that number. So it just becomes minus 10. Okay? What if we had something a little bit more, something like this, cd squared plus 4y z times 7cd squared minus 4y cubed z. Okay, now say you had to multiply something like this. So you're going to do first terms, outer terms, inner terms, and last terms. So this is going to be 49c squared, so c times c, and then d to the 4. So you add the exponents for d and d. Then this times this is going to be negative 28cd squared y cubed z. So because we have no common bases, we just write everything beside each other. This part here is going to become plus 28 y3z cd squared. And then the final one's going to be negative 16 y6z2, and that I get by y to the 3. So y to the 3 times y to the 3 equals y to the 6. So that's how I got that part here. And then z to the 1 times z to the 1 equals z to the 2. Okay, so that's how I got that part. So those are just on the side there. Now at this point, you see if you have any common like terms, sorry. And these ones, even though they're written in a different order, this part here and this part, they're still considered like terms. So because they have the same variables and they have the same exponents attached to each variable. So these two are like terms, and it's negative 28 plus 28, so that actually cancels that. And we're left with 49c squared d4 minus 16y6z2. And that would be our final answer. Okay? So just a short lesson on how to multiply binomials. I am going to be doing other lessons on trinomials and binomials, and then polynomials, etc. Binomials, polynomials. So I'm going to do a whole bunch of other examples. So this one was just focusing on using FOIL to do just the basic binomial by binomial type example. Okay, so I hope that helped you understand the topic.